We're going to look at the method of completing the square, so we can write a quadratic expression that's in this general form in completed square form. And I'll just point out at the moment, this video we're only going to look at cases where we've got an x squared coefficient of 1. So we won't be looking at 2x squared or minus 6x squared. This only considers where we have just x squared. So I'll write this expression out in completed square form. I've not changed the expression, I've just written it out in a different way. And there are times, as we'll see in other videos, when it's much more convenient for the equation or expression to be in this completed square form. But what we're going to look at is how do we get from here to here? How do we write it out in completed square form? So I'll write down another example. And the first step is very easy indeed. We just begin by writing out our bracket, and then the number we put in the bracket will always be half the number that's in front of the x term. So in this case the number in front of the x term is plus 6, so half of plus 6 is plus 3. So we'll finish off our bracket and square it, and then we'll add a number to the end, which is the second step, and the one that we have to think a little bit more about. But you can probably see the first step is quite straightforward indeed. So I'll write out another quadratic expression, and we'll carry out the first step. It's always the same with an expression like this. We start off our brackets, and then in the bracket we add to it half the number that's in front of the x term. So we've got minus 4 in front of the x term, so half of minus 4 is minus 2. And we'll finish off our bracket, and then we add a number at the end, and in this case we're going to have plus 6, and we're going to consider now why I chose plus 6. We're going to start by considering a simple quadratic expression, just so we can see what's going on. And so I'm going to carry out my first step, which is the step that's most straightforward. I'm going to start off my brackets and then look at the number that's in front of the x term, so plus 4, and halve that, so half of plus 4 is plus 2, and finish off my brackets. Now this expression is very similar to the one above, but it's not quite right, and I'll show you why if I expand it out. X squared plus 2x plus another 2x to give me plus 4x. So far so good. But then I've got this last step, which is plus 4. So this step 1 gives me the first term that I want, the second term that I want, but this extra nuisance term that I didn't want, it's introduced as well as the two terms above it which I wanted, this extra plus 4. But I can make the whole thing come good by simply subtracting 4, in other words undoing this plus 4, and these two expressions are now the same. We'll have a look at one more example, just so you get the idea. So we'll have, say, x squared plus 6x, and step 1 is straightforward, so we'll start off our brackets and then look at the number in front of the x term, which is plus 6, so we'll halve that, so half of plus 6 is plus 3, and finish off our brackets. And we know this is pretty good, but it's not quite right. And again, I'll just expand this out so that you can see for yourself what's going on. So again, I've got x squared plus 3x plus another 3x plus 9. So in just the same way, what happens, this step 1 gives you the first two terms that you do want, but unfortunately introduces this extra term which you don't. So if I compare this expression on the second line with the one above it, it gives me my x squared, it gives me my 6x, but it has also introduced this plus 9. So I'll simply make this come good by undoing that plus 9 by subtracting 9. So now if I was to expand this out, I'd get the x squared, I'd get the 6x, I'd get plus 9, but then I subtract the plus 9, so I end up with just the x squared and the 6x. So these two are now the same. After you've done a few of these, you'll see a pattern emerging. It's quite straightforward completing step 1, as we've seen, but what you'll see is the number that you subtract is always the square of this number in the brackets. So I square plus 2 and I get 4, so I subtract 4. I square plus 3 and I get 9, so I subtract 9. So if I write down another example here, the first step is quite straightforward. I start off my brackets, look at the x term and choose half the number that's in front of the x, and finish off my bracket by squaring it. And now I square this number that's in the brackets, plus 4 times plus 4 to give me 16, and subtract 16. And if you'd like to do this the long way by expanding the brackets and comparing it, please do so, but you'll find that this is a shortcut, if you like. So we'll finish by looking at a simple example of a full quadratic expression in the general form, and see how we change this to the completed square form. So now we've got x squared plus 4x plus 6, so this is perhaps what you're more used to seeing. Now to start with, I'm only going to look at x squared plus 4x, and then carry out the procedure just as we've done before, with x plus half of whatever is in front of the x term, and then square that. And just as before, the first thing we've got to do is deal with this extra nuisance that we've introduced, which is as a result of squaring this number here. So we've ended up with our x squared, which we wanted, our 4x which we wanted, but we've got an extra 2 squared if we were to expand these brackets out, so we'll subtract that 4. So at this point we've dealt with this part, and what we've written here is now equal to what we've got highlighted here. And then we mustn't forget we've just got this plus 6 as well. And then if I just collect these terms together, I end up with plus 2.